Welcome, my Math 2 people. We're moving on from our trig functions and heading into ideas around circles. So I drawn a circle here. I use my favorite tool, the compass, to make a circle. And we got to figure out first some vocabulary. There's the vocabulary we need to learn around the circle. First off, the circle is defined as a set of all points equidistant from a point called the center. So here's our center. That's why you can make a circle with a compass, because everything is the same distance from the center. Now that distance from the center, we call that the radius. Okay? Radius. Okay. And the radius of a circle is simply the length from the center to the circle. Okay? And the circle, again, is a set of all points equidistant from the point called the center. I've labeled my center here O. A couple other things we want to learn. Say we had two radii drawn on our circle. So we have now our point O here. I'll call this point A, and this point B. Okay. So this angle now that we've made, okay, we call that a central angle. Obviously, because its vertex is at the center of the circle. And a unique thing about this is that this angle, whatever measure this angle has, this piece here of the circle is the same measure. Okay. AB, we call that an arc. Okay. An arc, like arco iris. An AB, and we use the little symbol like that, like a little rainbow, an arco iris, except there's no iris, it's just an arc. AB. And the measure of whatever the central angle is the same as the measure of that angle AB. Now, when we did our degrees to radians thing, you may have come across that formula that the arc is equal to the measure of the angle divided by 360 times 2 pi r. Or we could simplify that to the measure, because that 2 and that 360 cancel, the measure 180 times pi times the radius. Now, if your radius is 1, then that's your conversion factor, conversion ratio for degrees to radians. So you put your degrees up there, divide by 180, multiply by pi, and you got the radians for that degree. So if you wanted to know this in radians, you would use this formula. If you want to know it in degrees, you just measure this angle with a protractor, which I left mine lying someplace and I don't see it. Okay, we'll get back to that in a minute. Okay. Now, there's another thing to know about these things. Okay. If we have a line that's, say, connected A to B, okay, it's kind of hard to draw on my little cage here. So a segment that connects 2 points on the circle but does not include, well, even if it does include the center, but it connects 2 points on the circle, we call that a chord. Okay. A chord. So if I put another point, say, here, well, let me just draw in my diameter. So the diameter is a chord. Is a type of chord. It's the longest chord in a circle. Every other chord will be shorter. You can prove that for yourself by drawing a circle and then drawing all the chords from it. And you'll notice that the diameter is the longest chord. It's straight across. Okay. Now there's a couple other little tidbits of vocabulary that goes along with this segment. Okay. We talked about a central angle. Okay. I'm actually going to draw another circle because this one's starting to get a little messy. Talked about a central angle. We talked about the chord and the arcs, okay, and how the central angle is the same measure as the arc that it subtends. Now let's take a point on the circle and then two other points on the circle. Let's call this A, B, and C. And if we connected those to make an angle, notice I'm not including the center. So A, B, and C. Should bring in some color on this. So this is what we call, now we have an angle that touches the circle in three places. An angle that touches the circle in three places is called an inscribed angle. Now, the unique thing about an inscribed angle is you notice we have, if I put in the central angle, let me bring in some color. If I put in a central angle that matches to the same point, we're going to discover something. Okay. This angle here is the same as this arc here. Okay. This angle here, what do you think? How do these two angles relate? Okay. Well, let's look at it a little more precisely. Let's take back to this one, okay, where I've drawn the diameter, and I'm going to inscribe I'm going to make a 90-degree angle. And it's easy to make a 90-degree angle on one of these things just by inscribing an angle such that its endpoints are diametrically opposed. Because this angle has endpoints at the two endpoints that are the diameter, the longest chord, that means this angle is a 90-degree angle. Now think for a minute. A straight line, a straight angle, how many degrees are in a straight angle? That's right, it's 180 degrees. And this inscribed angle is 90 degrees, but it cuts off a 180-degree arc. 180-degree arc. A semicircle. 180-degree arc. 180-degree arc is a semicircle. And 180-degree arc is cut off by a 90-degree angle. So if this arc, say, were, I don't know, 30 degrees, that means this angle here would also be 30 degrees. But what would this angle be? Well, if a 90-degree angle makes a 180-degree arc, okay, then what size angle is going to make a 30-degree arc? That's right, a 15-degree angle. 15 degrees. So we can say that with the central angle, the measure of the angle, BCC, we'll call this O, BOC, measure of angle BOC is the same as the measure of the arc BC. And the measure of the angle BAC is equal to 1/2 the measure of the arc BC. Okay, so these are some of the things that we're going to be playing with as we go through it. But I want to take you through a couple other things in this introduction of notes and lead you to where we're going. So we've talked about an arc. That's just a portion between 2 points on a circle, a portion of the circle between 2 points on a circle. A chord, which would be a line segment that connects 2 points on the circle. Okay. The longest chord being your diameter. Okay. We talked about a central angle, an angle who has a vertex at the center of the circle. We talked about an inscribed angle, an angle whose vertex is on the circle, 1 point on the circle, and who has 2 other endpoints on the circle. And now we're going to talk about a couple of, and we also mentioned that the arc length of a central angle is equal to the angle, and the arc length of an inscribed angle is twice that angle measure. Okay. So now let's take that a couple steps further. Okay. I'm going to draw another circle. And this is going to lead to what you're going to actually be doing. Okay. So I'm going to do this fast because we're up at 10 minutes and I don't like to go that long on these little. So what you want to do is you want to draw a circle of your own. Okay. Use the compass so it's neat, so it's an actual circle. Label its center. And then what we're going to do is inscribe a square. Okay. In order to inscribe a square, you first need a diameter. Okay. So you draw in a diameter, and then you're going to create a perpendicular bisector to that diameter. So remember our basic construction, perpendicular bisector, mark your compass more than halfway. Make it a little bit more exaggerated. Okay. Arc above, arc below. Go to the other endpoint. Arc to cross. Arc to cross. And now we have a perpendicular bisector. It's also created the midpoint. And now we can take these 4 points. Let me pull out some color. See what's a good color. How about blue? Feeling kind of blue. Feeling kind of blue today. And we can draw in a square. And now we have constructed a square inscribed in a circle. Okay. So your first assignment with all this work here, with all this stuff about here, is to do that. To construct a square inscribed in a circle. And you're going to discover something. Okay. Notice how these opposite angles, these are both 90-degree angles, and they both cut off half a circle. 90-degree angles cut off half a circle. That's one way you can always make a 90-degree angle inside of a circle, is if you make your endpoints at the ends of the diameter. Okay. And so that means this angle and its opposite are supplementary. And that's true for any quadrilateral, any four-sided figure that you inscribe in a circle. Its opposite angles will be complementary. I'm just going to draw one random thing. Did I say complementary? Supplementary. So that tells you that this angle here, it cuts off that part of the circle, and this cuts off the other part of the circle. So they're supplementary. This is going to be this much of the circle, whatever this arc length is, and this is going to be the rest of it to make the whole 360. So that means that opposite angles of any inscribed quadrilateral are supplementary. Okay. That's going to come into play. I'll give you the next part when I give you the assignment. But for right now, what you want to do is construct an inscribed square. Square inscribed in a circle. All right? More coming. Good luck.